I'm listening. Close. Close. All right, please stand for the pledge. I pledge allegiance of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
What is with your
All right, they still haven't returned my sheet of paper, so hot lunches, raise your hands. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16.
I turned in. I don't know what
Hot lunch, not hot lunch. 17.
Guys, lettuce, sweet and sour chicken. Yes, yes. It's not. I know. And you got it. And I didn't. Why do you keep your hands closed?
It's too much light. I need the projector on.
It's too much light. Let's turn off all the lights.
That's what Miss Emmons does. I just know there's some people that would literally fall asleep if I did that. No, but you can give him a gentle tap. Notice what I said, gentle tap. All right, get out your homework.
Yeah, it was a great idea. We had
Funny. We're not hitting anyone in the head.
At least I didn't have fire.
Remember, this is being recorded. So if you were to hit him in the head, they would ask for this as evidence of intent.
And then you'd be arrested. Well, I guess if he just doesn't fall asleep.
That would be the best thing.
And then he'd be arrested for assault. Or if he does fall asleep.
I'm not laughing.
Yes.
No, that's not.
Like that. Could I go away to jail for assault?
All right, quiet, please. Quiet, please. Thank you. All right, any questions on the homework before we grade? Yes. Number 8 says the following. In exercises 1 through 6, in exercises 1 through 6, you measured a segment each time. It says, name the midpoints. So you simply figure out how long it is, right? For instance, on question number 1, it was 8 centimeters long. Well, if you cut 8 centimeters in half, that would be 4 centimeters. Find which point is 4 centimeters from the start. Most of you probably used your eyeball and simply looked and said that looks about halfway. Now, if you mathematically check that with those calculations, then you're even more assured that you got the right answer. But I will say most people can look at that just with their eyeball and figure out the midpoint. Yes? Hurry up. All right, one person. Anyone else? Yes.
I have a reminder. Pull out your homework. I have it.
Right.
You actually have it.
All right.
I know, right?
So, 1 out of 3. Here we go. Quiet, please. Here we go. Now, it said that you needed to put both centimeters and millimeters. So, number 1 is 8.
It said A put in centimeters.
It says to the nearest centimeter and B to the nearest millimeter. So there's going to be an A and a B.
I thought there were sections A and B.
Well, yeah, B would be the same question, just do it to millimeters instead of centimeters. Notice I made it exactly like how I did it in class, where I had you do centimeters and the millimeters. The nice thing about the metric conversion is you don't need to remeasure it. You just simply need to move the decimal place once to the right. All right, number 1, it is 8 centimeters or 80 millimeters. Number 2, 8.1 is fine. Number 2, 4 centimeters or 40 millimeters. Number 3, 9 centimeters or 92 millimeters. Number 4, 4 centimeters or 38 millimeters.
3.9.
Sure.
Oh, I was like, why do you do? Yeah, I heard you. 8.
How do you convert centimeters to millimeters?
50 decimal.
King Henry died by drinking chocolate milk. 1 decimal to the right.
Or knock her dead body down chocolate.
It's got to make sense if you're going to make up your own thing. But it was a good start. All right. I can't condone the violence, though. All right, number 5, 8 centimeters or 82 millimeters.
I got 83 centimeters.
83 is pretty far off, right?
I'm at 7.3.
7.3 is definitely wrong.
Wait, say it again.
8 centimeters or 82 millimeters. Yes.
So, okay, I must have seen you do it wrong, because on the thing, it says you put the half line is a millimeter. Am I correct?
Every little tick mark is 1 millimeter.
Oh.
But for me, I'm measuring it I'm not even going to measure in millimeters. I'm just going to measure in centimeters. And then to answer the millimeter question, I'm just going to move the decimal place once. Okay, I can't hear you when you guys are talking. What? Yes. Agreed. But think about it. 8 centimeters. If we move the decimal place 1 over, it would be 80 millimeters. Now, why am I saying 78? Because this was probably 7.8 centimeters. I just rounded it to 8. Okay, but more precise, if you use millimeters, it's more precise. Okay? Absolutely. Well, yes, I can live with that. All right. What number am I on? Number 6, 12 centimeters or 120 millimeters. Yes.
I put 8.2.
That'll work.
I put 12.1.
8.3 is pretty far.
I had 12.3.
12.3 is pretty far off.
I got 12.1.
12.1 is good.
I got 12.2.
11.9 is good. Sure.
I got 12.2.
12.2 is just on the cusp of not being accurate enough. All right. Number 7. So then it basically says, hey, look at your answers and tell me which ones are about the same. And it literally uses the word about. So 3 is not about the same as 10, right? But 3 is about the same as 2.9. That's basically what they're asking. If you look at this, number 1 was 8 centimeters, and number 5 was also about 8 centimeters. So 1 and 5 are about the same, and 2 and 4 are about the same. Yes?
So, what happens if you got millimeters all around, but you got the other half already?
Take half off. Lastly, it's just asking for the midpoints. So the midpoint of number 1 is C. The midpoint of number 2 is X. The midpoint of number 3 is O. The midpoint of number 4 is I. The midpoint of number 5 is R. And the midpoint of number 6 is A. Make sense? All right. But how many you missed on the top? Here we go. Yes. All right, you need your protractors. For those of you that have your own protractor, look at it and make sure it has a hole or some sort of indicator of where the middle is. If you can't see through that, then you can't use. The last couple of years, they've been selling some protractors that do not have that feature. Even though it was in a metal fisker, they finally started putting a hole in it.
Maybe I'll come on.
Like for real. Wait, no, that's not your.
I just realized this rose is all girls.
Except for Nick and Peter.
Hey.
All right, look at the board. Let's see, we got a quiz on Friday. We'll talk about what's on it tomorrow. Here is your homework.
That's a very nice one.
Sorry. There's the calendar. Listen, please. Listen. Quiz on Friday. We'll talk about it tomorrow. Here is your homework. You will not need a I gotta confirm that. I don't think you need a protractor tonight for homework. Could be wrong, but I'm pretty sure you don't need a protractor.
You never know.
Somebody do me a favor, look through the homework. I do not believe they ask you to actually use a protractor to measure.
They do give us do those follow.
Yeah, that's true.
Yeah, we do.
They do? Okay. So you will need a protractor. So that means, are you listening? If you do not have a protractor, that means during student advisement, you either need to borrow a protractor of one of your fellow students, right? Or I'm not handing out protractors because I'll never get them back, right? So that's what we're gonna have to do. If you want to come in individually and use the protractor, that's fine, but I'm not gonna give you a bunch of protractors and never get them back. Plus, it was on the packing list for school supplies. You're supposed to have a protractor. Ready?
Yeah. I remember what's on here.
All right. How many people be truthful? You don't know how to use a protractor? Okay. So just a handful.
Oh, I know how to use it.
Then why is your hand in the air?
I said no. Oh, a protractor.
That's what I said.
It's a half circle. Do it.
Actually, they make full circle protractors.
Wow.
All right. All right, here we go. So this is a class on angles and angle measurement. It's more than just, hey, I know how to use the protractor, so I need to pay attention. Yes, use the protractor is the first part, but the rest of the class is a whole bunch of other stuff. Right? And I guarantee you it's some of the stuff you don't know. Here we go. Write this down, please. Box 1A. Box 1A. Write this down. Okay. Draw this, please. Leave space. We got to write a definition on the top. Draw that. What is that, by the way?
Angle.
That is not an angle. That is a ray. Who said line? Why is that not a line?
Because there's a little thing about.
Why is it not a line?
Because a line is just the line between the two dots in a ray that continues.
So a line doesn't continue? Why is it not a line?
Because a line continues in separate opposite.
In opposite directions. This one only goes in crappy boy band direction, right? One direction.
One direction's a pretty crappy.
Yesterday
you were saying one direction.
All right. If I have one ray, don't draw the next one yet. Wait for it. And I draw another ray. And since this is a smart board, you can press this. You can.
This is not a smart
I think I just gotta
board.
push harder. Press. Oh, there it goes. And then I can literally move it.
Whoa.
That's a smart board.
No.
I just moved it, didn't I?
Never.
Very smart board you got there.
All right.
It's definitely not just one.
What was the second thing I just drew?
That's a whiteboard.
What's the second thing I just drew?
What's an angle?
The second thing I drew.
Another ray.
Another ray. And then I put the two rays together and I made a.
Angle.
So you tell me what's the definition of an angle.
Two rays.
Write that down. That is the definition of an angle. It's a figure or a shape formed by two rays that share an endpoint. It doesn't say share, it says common. That means share. So angles are simply two rays that you push together so that they share a common endpoint.
Mr. Chartier.
Yeah.
I think I know how you did that.
I would hope you could figure out how I did that. Copy down the angle.
Oh, I know what you did.
You could
Yeah.
have just done one of those like slide things and word and
All right. So an angle is formed by two rays that share an endpoint. Okay. You've seen angles before. You've heard the word angle before. Here comes the new stuff.
Wait.
What's the name of that angle?
Acute angle from
Acute.
That's the type of angle. What's the name of that angle?
B. Angle A, B, C.
There ends up being four ways to name angles. Four.
It's a 50-degree angle.
Four. That's a type of angle. There ends up being 4. This is the new stuff for 7th grade. 4 ways to name the angle. They don't teach you how to name angles. They might teach you how to use a protractor, but they don't teach you the name. Are you ready? Are you paying attention?
Yes.
Some of my high schoolers struggle at this. Naming the angle. It's the type of angle. We're naming it. Hey, this is Fred, that sort of name. Okay.
That's Fred.
So let me show you how it's done. Listen, please. 4 different ways. 4 different ways. Here are the rules. You must stay on a black line. And by line, I'm not saying a geometric line. I'm saying these things. You got to stay on the ray. You cannot leave the ray when you name it. You must stay. You can't go backwards and then forward. You can only go in one direction. So we got to cover all 3 points. So if the rules are I can't leave the black line and I can't go backwards and forwards, where do you have to start to name all 3?
Hey.
You got to start on either A or C. You can't start at B. If I start at B and I go to A, then the only way to get to C is to go backwards. You're not allowed to go backwards or forwards, just one direction. So you must start on one of these points, A or C, and then stay on the black line and read me the 3 letters. What do we got?
C, A, B, C.
Or,
C, D, A.
now what's the shape? What's the shape?
Triangle.
It's not a triangle. What's the shape?
Angle.
It's an angle. Guess what the symbol for angle is?
This.
It's an angle. So this, we're going to write this definition down here in another couple slides, but not right. That is called the vertex. You never start on the vertex. You start on the other 2 points. And then we stay on a black line. Occasionally, you will see a number right here at the vertex. Do you see a degree symbol? I haven't given you the definition of degree symbol, but hopefully you know what that means. Do you see a degree symbol?
No.
Therefore, that is not its degree, that's its name. There are 4 different ways to name an angle. Here are the 4 ways. Don't start at the vertex, start at A or C, go around in one direction. So this is angle ABC. Notice I made B red. Why? The vertex is always the middle letter. The point, the common end point is always the middle letter. Or,
Is that a greater sign?
that is an angle symbol. It kind of looks like a less than symbol, but notice it's flat on one side. You see that? Okay. So this is angle ABC or
Angle 1.
or
CBA.
CBA. Write this down, please. Or,
1.
and there's a 4th way. Okay, so here are the rules. You ready?
Yep.
If the angle is sitting there all by itself, there are no other angles around it, there are no other angles attached to it, you are allowed to simply call it by its vertex. Is there any other angle other than this one on the board right now? You see this over here? This is high school geometry. You see how many angles are right here? 1, 2, 3, 4. There's a Z right here. We can't call angle 4 angle Z. Guess why not? Well, which one is angle Z?
Different angles.
There are 4 different angles here. Do you see them? 1, 2, 3, 4. I'm not talking about their names. I'm just saying there's 4
yeah,
angles. Notice on this one, if it's just B, the only angle possibly is this one right there. So when the angle is floating there all by itself, not like this, right? You can call it angle B. Hey, you see this Y right here? Is there any other angle other than this angle right here?
Yeah.
So we can call this angle angle Y or angle 3, either one. Hey, this is the hardest thing to wrap your head around. Like I said, my high school students have problems with that. Hopefully, when I get you for, because I didn't have them for course 1. So this could be called angle B just by itself, but only when it's floating there by itself. Not when there's 4 other angles that could be called the same thing. And then lastly, we could call it angle 1. This angle 1 thing is used a lot in high school algebra, but rarely will we use it in course 1, right? We typically have this one here when it's a messy diagram like this one. When there's 4 angles, we got to differentiate between this one, that one, this one, and that one. We put numbers there. It's just easier to name it that way. These are the 4 ways to name an angle. Notice each time you have an angle symbol. Questions? This is new for you this year. What?
Why come with the angle instead of ARC?
It's just a different option. It's your option. Isn't it easier to write angle B than write ABC?
Yep.
But
Or T.
on this one right here, if this 4 wasn't here, guess what this angle actually is?
B.
Y, Z, X. And you're forced to use 3 letters because otherwise you can't call an angle Z because Z could be this angle, this angle, this angle, or this angle. I don't know which one it is. So sometimes you're forced to use 3 letters. Other times when the angle is just floating here all by itself, there's nothing to confuse it with, we could call this angle angle X. We can't call this angle angle Z because I don't know what Z refers to, which one of the 4. So in that case, then you got to use 3 letters. Who's confused? What are you confused
So
about?
you just go straight like.
And then if you choose to use the 3 letters, you have to stay on a black line. You can't go forwards and backwards. You can only go in one direction.
And then do we have to choose do ABC or just do?
Tonight for homework, they're going to ask you to name an angle, or they're going to name an angle you have to be able to identify. And it's your choice. So in box number 2, you got an angle. Give me the 4 ways of naming that angle. Go. Write it down. Paper. On your paper. Everybody a chance to get it done. Hey, the angle's floating there all by itself. There's no way you can confuse it. All right, Parker, give me one way of naming this angle. Angle what? He goes with the easiest way, right? Angle E. Very good. Malachi, give me another way. Angle. Okay. Angles always either have 1 or 3, never 2. So D, E, F. Make sure your angle symbol's there. Another way, Ace?
Bob.
No, can't name it Bob. Go.
4.
Angle 4 with the symbol in the last way. FED. There are the 4 ways to name that angle. Be careful. The only time you're allowed to call it angle E is when it's only by itself. In this case, you cannot call this angle right here angle Z because there's 4 angles right there. Yes.
So why is there 4?
So you see this picture right here? It's confusing. What is this angle right here? So sometimes, and especially we'll see it in high school, they won't use letters. They'll just have numbers there. So because it's way easier. 1, 2, 3. Can you tell which angle is which angle now? Yeah, if I say angle 2, you know where to look. If I say angle 1, there's no degree symbol. It's not saying how big the angle is. It's just saying that's the name. Good? Yes?
So what do we write in box?
I'll tell you that. We're not there yet. Okay. All right, moving on. So we need to define vertex because we just kind of glossed over that real quickly. So in 1B, her question, what do we put in box 1B? Put the definition of a vertex. A vertex is the intersection of the 2 rays, right? It's where the actual angle is formed, right? The definition says the point of intersection of the 2 sides of the angle. The 2 sides are made up of rays. The vertex is that right there. And I put a circle on it. You don't need to draw a circle on it. That is the vertex. The plural of vertex, if you talk about a triangle has 3 of these things. We don't say 3 vertexes, right? We say vertices. Put it away. Away means not there. In your bag. Put it in your bag. Put the book and the whatever was in that container in the bag. We good? Vertex or vertices? Okay, it turns out the vertex is where we measure angles from. The vertex is where you will put your protractor here in just a second. We don't put our protractor on A or C. We put it on B. That's how we measure an angle. All right. I don't have you write down this definition. You should have heard this word before. It's called degree. It's the angular measurement. Here's what my math teacher originally told me. Look at my hands. How much is it open? We're not talking about inches. We're not talking about a distance, because the angle could be 4,000 feet long. We're talking about how much space is between the two rays. Okay? That is how we measure angles. It's measured in a unit called a degree. Okay? Degrees can start at 0. It can go to infinity. Like, wait a minute, if you go around, you're back where you started from. You made 360. Turns out, like a car engine or a wheel on a car, the wheel continues to spin. It never stops. So if it spins for 5 minutes, how many degrees did it go? Well, it went around a whole bunch of times. So degrees don't stop at 180. They don't stop at 360. They continue because a wheel can continue to spin. So it's still turning degrees. Okay? At least in the 7th grade, you're never going to see an angle bigger than 180 degrees. They exist. Right? When you get to high school is when you start seeing angles bigger than 180 degrees. But for 7th and 8th grade, you only see 180 degrees and less. Okay? What's the symbol for degree?
Little Chinese
Little dot. So that symbol in red there is degree symbol. It's not a 0, right? It's an indicator. Yes.
So it like goes where the exponent would
It does. It goes right where the exponent would go. Okay? All right, so let's talk about measuring. So we measure angles in degrees. This isn't the only way. When you get to high school, you learn another way of doing this, right? It's called radians. And if you have a scientific calculator, you may have wondered, why does it say degrees at the top? Why? Because your calculator is in degrees. The second, well, it's actually 3 measurements we use, but degrees and radians are the common ones that we'll use from now until high school. So this says 45 degrees. So your protractor, the only bad thing about it is that it has 2 scales on it. Look at your protractors. There are 2 scales. The one that is on the outside starts at 0 on the left. The one on the inside starts at 0 on the right. It's the same scale. They just write it backwards. This allows you to measure angles from left to right or right to left, depending upon which way the angle opens up. Look at me. The angle is opening up from the right. Look at me. The angle is opening up from the right. Look at me. The angle is opening up from the left. Depending upon whether the angle opens up from the right or the left, depends upon which scale that you will use. Did everybody see the 2 scales?
Yeah.
The number one mistake that students will make is they use the wrong scale. I will try to help you not make that mistake. Notice 2 scales. The parts of the protractor that are important are, first off, this index right here. Yours is probably a hole. Mine's a little notch. Do you see where your hole is or your notch is on your protractor? Yes? This is what you line up with the vertex of the angle. You literally put that on the vertex. Okay? You see this line right here that goes from the index hole, right, across to either 0 or 180? That is what you line up with one of the rays of the angles. Right? The angle is made up of 2 rays. You will line up this 0 or this 180 line with that ray.
What do you
So that is the line that you will line up with one of the rays. It's got to be lined up precise. The number one reason why kids get the wrong answer is they're just not very precise. I mean, look at it carefully, line things up. And then we got to read the right scale. I'll help you with that in a second. So let's see how this is done. This is my explanation. You don't find this in any math book. This is my explanation of how you don't screw this up with the 2 scales. I say you either have a little angle or you got a big angle. You see that? Hey, is that little or big? Is that little or big? So when we line up our protractor, notch goes on the vertex. I line up the bottom one of the ray. When I read this, notice there are 2 numbers here. These people can probably see the number. Maybe in the back they can't. This says either it's 21 degrees or it's 158 degrees. Was this a little or a big angle? And you better read the little number. Conversely, if we line the notch up with this vertex and we line up the bottom ray with the 0 line, I get 2 numbers here, either 50 or 130. Is this a little or a big angle? It's got to be 130. Can't be 50. Okay? if you really want to think this through and you want to say, oh, does it open up from the right or to, I mean, okay, we can use that as well too. Okay. All right. Secondly, the second biggest mistake is they'll see a number, confirm it's the right number. Notice if it was like this, you see what I just did? Okay, you see where the shadow is? It's either between 130 and 120 or 50 and 60. Well, it's a big angle, so it's got to be between 120 and 130. People that aren't paying attention will see if it's really close to 130 and say, oh, that's 133. Well, it's between 130 and 120. It can't be 133. It's got to be 128. You see how you can make a mistake on that? All right. This is best done with some practice, so let's do some practice. Let's do some practice. Okay, little or big angle. Okay, so when I place this here, this notch right here goes on my hole or the notch of the protractor. This line right here gets lined up with my 0 or my 180 line. The people up front can see that I lined up the shadow exactly with 0, 180. You see that? The other shadow goes right here. It's either 20 or 160. What could it possibly be? It's got to be 20 degrees. It's a small angle. Is anyone confused about small or big angles? Okay. Small or big angle. So when I line up the notch with the vertex, I line up with this ray with the 0 or the 180. Notice I'm lining that up perfectly. You're going to be looking through your protractor because yours is clear. It either says 50 or it says 130. What could it possibly be? Why 130 and not 50? Because it's a big angle. Okay? You tell me, little or big. And by big or little, I don't mean length. I mean how much is it opening? Is it opening a little bit or opening a lot? Okay. All right, so this isn't a big angle because it's physically big. We're talking about the opening. Does this open a little or open a lot? It opens up a little bit. So when I place my notch or my hole on the vertex, I line up the bottom ray with the 0 line. You see what I did? I'm trying to be as precise as possible. This either says it's 24 or it's 156. Which one could it be? Gotta be 24. Usually I'll have some kids say, well, I thought this was big because look how big it is. No, it's the angle that opens up. Yeah. Yeah, let's round it. There's 1. Not the 10th. There's 1. So 151, not 151.3, that sort of thing. Yeah.
Our papers, like on the.
I'm going to describe that here in just a second.
Like the line
Just a second. Just a second. She has identified an issue because she's working ahead. So the issue is this. Look at that sucker. Is that a big or a little angle?
Big. Little.
That is a big angle. Notice the opening. It opens a whole lot. So what she was trying to tell me is there's a problem. When the angle is drawn small, when you throw your protractor up to it, I can't read it. So guess what you got to do?
Draw lines.
You got to take the edge of your protractor, we call it the straight edge. You place it, click the button here in a second, Jaden. You got to put it right here, then guess what you got to do with your pen or pencil? Use a straight edge. Make it as straight as possible. Click. And you put a line right there. Sometimes you got to do it to both sides. So once again, I'm going to line it up, click. And I'm going to, you see what I did? Now when I throw my protractor up, it lines up perfectly. You said this was what, little or big angle?
Big.
So it can't be 36 degrees. It's got to be 144, maybe 145. Who's lost? Can you think you can measure all those 4 angles by yourself?
Yes.
Do it. Anybody need it? Usually there's a couple people that need help. Like I'm not clear. I don't know what to do. You need to be within 1 degree of the answer, plus or minus. Yes. That's the next thing after this. That's the next thing after this. You need to be within 1 degree. 1 degree. That's plus or minus. The more accurate that you are when you draw your lines, the better off. There's going to be a few people that aren't going to be within 1 degree. I'll just say that usually happens. Yeah. That is lined up perfect. Now, the problem is we can't read this, right? So this is one of those ones where we have to extend this line. So go ahead and extend the line all the way to the end of your page. Keep going, end of the page. Now measure it again. Try to be really accurate. See how your line is not on the arrow right now? Now it's perfect. Now you can read what it says. Is that a big or a little angle, by the way? That's a little angle. So it's got to be about 50, yeah, maybe 51, maybe 50, something like that. Sounds good. No one needs help? That's a little angle. Well, let's line that sucker up. Put it on the vertex. There you go. That looks perfect. So it looks to be about 50, what? Right or greater.
So I'd write 51.
51 or 52. Come on. Yes. Yeah, but the hole has to be on the vertex. This is why this is, I hate this protractor. I hate it. The problem is that you can't see it lined up right now. What you gotta do is you gotta extend that line all the way to the edge. So do that every time. Extend it all the way to the edge. You don't keep it stuck. Now when you put it on here, you can see you can line this up. Because this could be turned like this and you wouldn't even know it. Now when I do this, see how I'm lining up down to 180? And the other line, is that it right there? So it goes to
So that would be
29 or 20. As long as that line is straight, right? Okay. All right, let's check our work. The first one, I measured with 2 different people. It looked like both of them lined it up really accurate. One person got 50, one person got about 51 or 52. What did you guys get?
53.
Okay. I get 52 when I did it. So 53 is within 1 of 50. I'm not saying maybe 53 is the right answer. Maybe it's 51. But I'm saying we should have gotten about 52-ish. Okay. Bottom one, what you guys get?
28.
28, 29, 31. Ooh, those are pretty different. I got 29.
I got 29.
So 28 or 29, that's back on 30 is fine. Well, 31's kind of a bit outside the thing. 27 would be about a bit outside.
I got 29.
Upper one.
133.
By the way, I was helping Abby. She's got one of those
Like this.
Fisker ones. So she had to extend both lines because you can't see through the protractor. Okay? So you have to extend both lines there to make sure things line up.
I can't like
Because you don't have what I just said. All right, what did you get for an answer?
I got about 60.
6-0? Guess what he did?
You
read
read
what?
wrong.
He read the
I mean,
wrong
1/3.
scale.
I mean,
Notice it's a
1/35.
big angle.
No, I mean, I read wrong, but I mean,
Oh.
135.
135 is just slightly off from what I got. You know, would I mark that wrong? Probably not. Oh, by the way, I'm not going to have you use that protractor on the test, so I'm just saying that it's not as accurate. And the last one,
90 degrees.
93. didn't
I
even
actually got 91 when I measured mine.
90 degrees.
But 90 would be within 1 degree, so we're good. All right, questions on how to use a protractor. The rest of the class is taking notes. Okay?
What about
So lots of notes, lots of notes. Much of this you might already know, but some of it you don't know. So here we go. Recall. When we measure a segment with a ruler, this is called what? The measurement or the name?
Yay.
This is called the name because it's got the symbol over it. How do we designate the measurement? Without the segment over the top. So if we're measuring it, we do the same thing for angles, just slightly different. You ready?
Yeah.
Okay, same concept. What's the name of this angle?
B.
Okay, so the name of it is angle B. If we were to measure it, well, how do we write that?
B.
Here's how it's done. This is weird. This is new. You've not seen this before. If we want to say how big it is, we take a protractor, we measure it. We write it with a little italicized M. Guess what the M stands for? The measurement of angle B, and then we put an equal sign and whatever it is. Okay? This is how it's done. I got to make apologies. I don't like this. I think you should be able to put an equal sign after it, but you can't. This is for congruency. This is for measurement. Okay? Yes,
On the homework thing, it doesn't really give you the letter of the.
it doesn't. So you don't need to write the measurement. You just need to put the answer. Okay. So classifying angles, I already heard a couple people already throw these words out. Some of you may have this memorized, many of you don't. So we need to write this down in box 4. There are 4 boxes in box 4. We're going to go from smallest to largest, and it's not the largest angle, it's just the largest one that you will see this year. The smallest type of angle is called, write this down please, 4A. Acute angles are angles that are smaller than 90 but bigger than 0. Smaller than 90, but bigger than 0. 0 degrees isn't an angle.
100.
It's a ray or a line.
What if we have a 1 degree?
That's an angle.
Wait, what if you go all the way around and then you get to 0?
Good questions. We'll talk about that in high school. Good question. Take a guess. What do you think?
It'll just be 360.
It would be 360. Go around twice.
720.
That's literally where skateboarders get the name. It's
Yeah.
math.
I know.
Right.
Skateboard.
All right.
And 1080.
Right. It comes from geometry. Okay. Everybody got that one? What's the next angle?
Right angle?
If you are exactly 90 degrees, you are called a right angle. You see this little square right here. Why is there a square? Turns out that all 4 angles of a square are,
90 degrees.
that's why there's a square there.
Why is there?
We'll see in a second. So right angles are exactly equals 90. Notice, remember the M means measurement of angle C is 90 degrees. You don't need to draw the shape, you just need to draw the names of the angles. All right, what's the next one?
Obtuse.
Obtuse, obese, fat, right? Obtuse. If you are between 90 and
180.
180, you are called obtuse.
Which means fat.
It also means that it's a language arts term as well too. If you're being obtuse, you're not being very precise. You're kind of talking around the issue.
I'm very obtuse.
When someone obtuse, you're like, get to the point. Just tell me what you want. You're being obtuse.
I'm obtuse.
That's kidding.
All right, obtuse. You're bigger than 90, but you're less than 180. Which ace would leave 1? Which would leave 1 angle.
Oh, yeah, I don't know what the last one.
Elizabeth, can you figure it out?
Oh, I know where
Oh,
it was.
big boy angle.
I like that. What?
Chungus.
All right, if you are exactly 180, you are called a straight angle. A straight angle.
It isn't demonstrated.
Right. Straight angles. This is one of the main things we use in high school geometry, straight angles, believe it or not. We use this nearly every day. Straight angles. That's one that's equal to 180 degrees.
Some of these problems like really complex on the phone. Not the ones we have to do.
Yeah.
All right. Jaden, guess what we're doing in the next box?
Labeling each angle.
Label each angle by what you measured. If you measured that last one to be 90, then you have that type of angle. If you measured yours to be 91, you got a different type. So the next box, just give me the name. Should take you 10 seconds. Right? Anybody lost what I want you to do?
Middle angle, big
Keegan, this one is?
angle.
This one is acute. What's this one?
Cute.
Acute. What's this one?
Obtuse.
Now it depends on what you measured.
Right.
If you measured 90, then yours is, and if you measured 91, it's obtuse. If you measured 89, then it's acute. That's why there's a question mark.
I didn't measure it. I just eyeballed it.
Right. Questions on how to name angles. This is more like what homework will be like.
I didn't.
We have to make it.
Yes.
How do
All
you
right.
do that?
There are more names, right? More names. Here we go.
The dog-
Recall. Listen, please. Recall that, remember we put an equal sign for measurement? And when two things have the same measurement, but we talk about their names, we don't put an equal sign, we put a congruency symbol. Congruency means the things, different things, have the same measurements. We have the same thing for angles. when two angles have exactly the same measurements. Hey, this is angle B, A, and angle B. Not the same angle. One's red, one's blue. One's A, one's B. But if their measurements are exactly the same, if that one's 30 degrees and this one's 30 degrees, what do we say about the two angles? Angle A is congruent to angle B. Once again, this is how the congruency symbol is used. It's a hard concept to wrap your head around. Like, wait a minute, but it means their measurements. Yeah, it does. But if we're talking about the names of things, why isn't your pencil moving? You're talking about the names of things. We use the congruency symbol when their measurements are the same. If we're simply talking about how big a thing is, then we use that little M for angles. The measurement of angle A is 30. Then we do put an equal sign. I don't forget if it was this class or the other class. I said, here's the geometry book. Open up the book. Every single page in the book uses this symbol more than one time. Congruency. Every single page in the geometry book. Even the table of contents. Well, of course I'm exaggerating. Right? Yes.
We never go.
We are not there yet. We'll get there.
No, it was.
All right. You guys are like jumping ahead. All right. Do we have this copy down in box 6? Congruent angles. Two or more angles are congruent if their measure of their angles are equal. The measure of their angles are equal. Yes.
On the homework it says it's together, but I don't understand that. So
Say it again.
Use a protractor to draw an angle congruent to.
So they're trying to have you to draw two angles that have the same measurement. Okay.
It says exercise 5.
Well, literally where it says exercise 5. So exercise 5 is right there. All right. Moving on.
Angle exact like that.
Write this down, box 7. Would answer her question. When you have two segments, you see the two segments? Draw that slightly, make it small. When you have two segments that intersect, and you take a protractor and you measure it, and that measurement comes out to be precisely, take a guess, 90 degrees, we give it a special name. It is called that the two segments are perpendicular to each other. Perpendicular is an important thing. Look everywhere around the room. Look up. What's the angle? Hey, look at the corner. Guess what that measurement is? Look at the corner of my board. Guess what the measurement is? Human beings. Look at your book. Look at the corner of your book. It's we don't see 82 degrees all over the world. They don't exist. You might find, listen please, you might find something at 82, but literally in this room, I guarantee you there's 1,000 things that are 90 degrees. 1,000 in this room. Okay? Because that degree is mentioned so many times in our world, that's why that 1 degree gets a special name, perpendicular. It probably exactly. It's immense. Human beings like 90 degrees. We like it. I don't know why, but we like that 1 degree. So write this down, please, box 7. Now this does, listen please. This doesn't say perpendicular segments. We could say that. It says perpendicular lines. When the lines intersect, they must intersect, and when they form right angles, we say that the two lines are perpendicular to each other. If they intersect, they form 89 degrees, then we just say they form 89-degree angles. But when they form 90-degree angles, like everything on the ceiling above us, right, is 90 degrees, right? We say that those intersect and they form perpendicular lines. Yes.
That circle thing is 90 degrees.
There is 9 degrees in that circle thing, yes.
Wait, there's 90 degrees in that circle.
Sure.
Yeah.
You know it as a
Big school.
with a plus in the middle of it.
That's called a
You know, it looks like a pie chart. The pie chart.
Right.
doesn't have a question.
All right, write this down, please. Okay, yes.
Write it out. So like AC. How would you write that?
Good question. In fact, we write it so often we have a symbol for it. Guess what the symbol is? An upside down T is the symbol for perpendicular. You're not going to see that this year, but you will next year.
You didn't connect it.
So an upside down T means it's the perpendicular symbol. Okay? You guys are talking a bit too much. What you will see this year when things are perpendicular is they will put this little square. Almost always it is red. Not sure why, but they always make it red. When you see this little red square, guess what they're trying to tell you?
90-degree angle.
It's perpendicular, it's 90 degrees. Next year is when you start seeing the symbol for perpendicular. Okay, there it is, right there. So we would say that AB is perpendicular to CD. You guys aren't paying much attention. You're off in your own world right now. You stop. Okay. So we would say that line AB is perpendicular to line CD. This year, you're not going to see this that much, but you will see the little red square always. Okay? And then the issue is when you get to high school, sometimes you see it, sometimes you don't. High school uses more the notational form rather than a little tiny square. Not always. They see it a lot too. Okay, who's lost on perpendicular lines? Pretty easy concept, right? All right, open up your books. Look through your homework. Who's got a question? Yes.
How do you draw an angle with a protractor?
How do you draw an angle with a protractor? That's the best question yet. Watch me. Step number one, are you copying an angle or are you making one just for yourself?
You're making one. It said just you have to.
Step number one, angles are made with what?
Lines.
No, they're not made with lines. Rays. Step number one, draw a ray. So I need a point and a straight edge. Take your straight edge, draw.
Wow.
Now rays have 2 points, so we got to give this a name.
A.
A and
C.
I heard B. Step number two, take your protractor. How many degrees do you want to make it?
75.
Let's make it 75 degrees. I take my protractor. I put the notch or the hole on the end point.
Okay, that makes
I read my scale till I get to 75 and I put a dot. You see what I did? I remove it and do what?
triangle.
Me personally, I'm going to name that dot
Z.
C and then I play connect. And you're done.
Z.
You can't name it Jimmy,
Oh.
but you can name it whatever one of the 26 letters that floats your boat.
What about C?
All right. Any other questions? Right, please. Any other questions on the homework? That does it. All right, stay in your desk. Right, you can chit chat until we're done, but stay in your
My
desk.
question, I don't know if my homework is right now.
No, don't turn your homework early. Say, Matt? Well, it depends what you're making. Are you making a large or a big angle? So you go from 0, where's 0?
Big angle.
Well, if you do it from this side, then it's going to be 75 this way. But if you do it from this way, 75 over here. You want to open from right to left, from left to right. You're up. You make your own choice. All right. I do need my sit. This is how I don't know if I get them back. If you walk up, sit. If I walk to everyone, I know if I get my protractor. Some people hand it, I don't know. All right, my protractor, your protractor. My protractor, your protractor. See, this is what. I don't know. You have your own protractor, yes? Protractor, yours and mine.
Sir, what are you Sir, what are you doing? That's Chief, what are you doing?
Okay, I only gave one instruction, that was stay in your seat, Jaden. All right, e-learners, any questions? Josh, any questions? No? All right, see you tomorrow.